Meet the polar vortex, a chilly whirlwind that has been gathering in the stratosphere since August and is ready to make a big impression on the northern hemisphere this winter. So far, a robust wind current known as the polar jet stream has been keeping it at bay. Unfortunately, the jet stream is gradually losing its vigor, and signs suggest it may weaken even more in the coming months. If this continues, there's a chance the polar vortex could break down, unleashing a blast of freezing air across the United States, Canada, Northern Europe, and Russia, something we've never seen before. So, what harm can this polar vortex cause to the world? Which countries of the world will it affect? Let us know about it in depth. What is the polar vortex? You are watching Cosmic Discovery. The polar vortex is essentially a low-pressure system that forms in the upper atmosphere, situated above the troposphere where most weather events unfold. It consists of a substantial amount of extremely cold air that swirls counterclockwise around the North Pole and clockwise around the South Pole. Surrounding these vortices are robust jet streams, high-speed air currents that serve as barriers, dividing the frigid polar air from the relatively warmer air found in the middle latitudes. Climate experts are currently exploring the possibility of the polar vortex undergoing a significant transformation. But what does that really entail? Well, it implies that the substantial whirlwind hovering over the North Pole could decelerate, fragment into smaller vortices, and even alter its course entirely. These shifts can lead to serious repercussions for worldwide weather patterns, particularly during the winter season. The primary brunt is anticipated in Canada and the United States, while Europe and Siberia may feel the effects to a lesser extent. What triggers this phenomenon? Is it a new occurrence, or has it happened in the past? And if it's occurred before, how serious might the consequences be this time around? Let's delve into these pressing questions. To comprehend why the polar vortex might collapse, it's essential to explore how it operates. So, why do polar vortices exist, and what keeps them going without a pause? The simple answer lies in temperature differences. Consider that as the Earth rotates, sunlight distribution isn't uniform, with the equator consistently receiving more sunlight. The air immediately above the equator heats up more than the air at the poles due to this uneven heating. This temperature contrast results in low pressure around the equator and high pressure at the poles. The Earth's thermodynamics play a crucial role in this phenomenon because cold air exhibits the property of taking up less space. When a mass of air cools, it contracts and occupies a smaller area. As a result, more air particles can be densely concentrated in that space, adding mass and elevating the pressure. Conversely, hot air expands, occupying more space, leading to the separation of particles and a decrease in particle density, resulting in lower pressure in that location. In essence, hot air induces low pressure, while cold air generates high pressure. Now, how does all of this tie into the polar vortex? Given that the air at the equator typically maintains lower pressure than the air at the poles, the cold air from the polar vortex naturally tends to move towards the equator, where there is more available space. Occasionally, the air in high latitudes in the northern hemisphere can breach the vortex's boundaries and move beyond them. Now, let's unravel the mystery of how the frigid air manages to escape the confines of the polar vortex. This escape is orchestrated by a phenomenon called Rossby atmospheric waves. These waves play a vital role in redistributing heat from the tropics to the poles and ushering cold air from the poles toward the tropics, all in a bid to restore equilibrium to the atmosphere. Simultaneously, the Earth's rotation imparts a rightward rotation to the atmosphere in the northern hemisphere and a leftward rotation in the southern hemisphere, a phenomenon known as the Coriolis force. Rossby waves owe much of their behavior to the Coriolis force. When a fluid moves from the equator toward the North Pole, it veers to the east, while a fluid traveling toward the equator from the north is deflected to the west. This Coriolis effect is a key factor in the formation of hurricanes. The directional spin of hurricanes hinges on their point of origin, whether it's from the north or the south. When a hurricane originates in the northern hemisphere, the Coriolis force deflects the moving air to the right, causing the hurricane to spin counterclockwise. Conversely, in the southern hemisphere, the Coriolis force deflects the air to the left, resulting in a clockwise spin for hurricanes originating in that region. This phenomenon is a consequence of the Earth's rotation, and it plays a crucial role in determining the rotational direction of hurricanes based on their starting location. Within the polar vortex jet stream, wind speeds can reach a staggering 250 miles per hour, surpassing the strength of a Category 5 hurricane by 60%. However, a shift is expected this winter, and the consequences are anticipated to be quite severe. Before delving into the aftermath of a collapsing polar vortex, let's first explore the elements contributing to its potential breakdown. The establishment of polar jet streams hinges on temperature and pressure differences between the equator and the poles, coupled with the Coriolis effect. These jet streams, in turn, corral the frigid winds of the polar vortices over the poles. If the polar vortex weakens or collapses, it may be due to a less robust jet stream incapable of containing it. Why might this weakening occur? A diminishing jet stream indicates a decline in the forces generating these high-speed air currents. As mentioned earlier, the Coriolis force is a constant result of the Earth's rotational speed, unaffected during a polar vortex collapse. Thus, the weakening or collapse of the polar vortex might arise if the temperature contrast between the poles and the equator diminishes, leading to a less stable or more erratic circulation. This shift can make wind patterns and the jet stream less predictable, deviating from the usual circular path around the poles. So let's dig into the next question. Has the polar vortex ever collapsed before? Well, it turns out that polar vortex collapses aren't all that uncommon. They actually happen every few years, and the intensity can vary. When these collapses occur, they often bring about historic blizzards and set some seriously chilly records. It's important to keep in mind, though, that not every winter cold spell can be blamed on the polar vortex. However, some of the most intense snowstorms in US history have been linked to these vortex events. Take, for example, the Great Blizzard of 1899, which stands out as one of the top 10 worst storms in US history. Although there have been several other examples of polar vortex collapse, none were as impactful as the sudden stratospheric warming event in December 2012 and January 2013. This specific event caused a massive blizzard across the tri-state area and colder than normal conditions in the UK. The collapse during 2012 and 2013 is one that brought polar vortices into the spotlight and received widespread attention in the mainstream media. That same year, the polar vortex reformed, gained strength, and then dissipated again in early January 2014, contributing to another winter season with record-breaking extremes. So now we understand what causes the polar vortex to collapse, and we know that it has happened quite a few times in the past. The question now is, what does the forecast look like for the near future? Polar vortices at the North Pole typically begin forming in August and gain strength as winter approaches, reaching their peak intensity in December when the stratospheric temperature is at its lowest and most perilous. Reports from September 2023 confirm the initiation of a polar vortex over the North Pole, rapidly gaining strength. While no other model can precisely predict its evolution until January, the vortex is undeniably taking shape and intensifying as stratospheric temperatures continue to drop. Now, let's delve into the question: what's causing these abrupt stratospheric warming events that lead to the collapse of the polar vortex? The answer lies in El Niño. El Niño is a phenomenon that occurs when the surface waters of the eastern Pacific Ocean become unusually warm, influencing weather patterns and climate in both the local region and beyond. El Niño events occur sporadically every few years, typically around Christmas time, and may persist for several months. The impact of El Niño is substantial, affecting ocean currents, fisheries, agriculture, and biodiversity in the affected areas. Additionally, its influence extends globally, as it releases waves of unusually warm air towards the poles. These warm air waves are responsible for triggering some of the sudden stratospheric warming events that have been observed. A significant correlation exists between the occurrence of sudden stratospheric warming events over the North Pole and El Niño events. The intensity of the El Niño event directly influences the strength of the associated heat wave, which in turn impacts the magnitude of the stratospheric warming event. As the stratospheric warming event gains strength, the likelihood of a collapse in the polar vortex increases. On average, 2 out of 3 sudden stratospheric warming events result in the disruption of the polar vortex. We are currently in the midst of a confirmed El Niño phase, which achieved moderate strength in September. At present, there is a 95% likelihood that it will intensify into a strong El Niño by December, reaching its zenith in January and February. During this peak period, there is a significant probability that it will generate intense heat waves directed toward the poles, leading to robust warming events in the stratosphere. This, in turn, has the potential to disrupt both the jet stream and the polar vortex. The situation presents a dichotomy. On one hand, we observe a strengthening polar vortex, while on the other, the intensification of El Niño poses a potential threat even to the most resilient polar vortex. It appears that we may be on the precipice of an impending freezing catastrophe. Despite the looming danger, there is a silver lining. The most severe repercussions of a polar vortex collapse are brief, characterized by extremely cold blizzards and spells. The real threat lies in its potential to happen suddenly, leaving us with limited options for preparation. Therefore, it is important to be proactive and prepared for any unexpected situation. Take the necessary steps to prepare yourself as uncertainties abound. What do you think about this polar vortex incident? Do tell in the comments. And subscribe to Cosmic Discovery channel